So our question is, a moving block having mass m collides with another stationary block having mass 4m. So the lighter block comes to rest after collision. So when the initial velocity of lighter block is v, then it's asking what will be the value of coefficient of restitution will be. So we need to find E. So now what we will do here, we will draw whatever it is given to us. So what it is given to us, we have been given that lighter, a moving block, small m, it is moving with, so this small m is moving and it collides collides with another block that has mass 4m. So this is another block, and this is a block, so this has a small mass m and this has the bigger mass 4m. So now, so the initial velocity, that is u, for the small mass is u itself, and the final velocity v is equal to 0, because the lighter block is coming to rest after the collision according to our question. So here u will be, for the bigger mass u will be 0 and v will be v itself. We need to find it. So now according to conservation of momentum, we will find out m into u plus 4m, that is bigger mass 4m, into that velocity, initial velocity 4m into 0, equal to lighter mass m, small m, into small m into 0 plus 4m into that final velocity 4m v, 4m v. So mm get cancelled from here, m and m get cancelled, and this also get cancelled, this 0 and this 0 get cancelled. And now what we will get after all the cancellations, you will find out that we get u equal to 4v. This is our first equation. So now we move to finding the E value. We know the formula of coefficient of restitution. It is minus v1 minus v1 minus v2, then upon u1 minus u2. So we were given that the value of v1 was 0 minus v2 was v, 0 minus v, and u1 v minus 0, u minus 0. So what we will get from here is, we will get minus and then bracket minus b, so it will become plus v upon u. So v upon u from this first equation and from this second equation, if we see, we will get nothing but 1 by 4. So 1 by 4 in decimal form is 1 by 4 in decimal form is 0.0.25. So our question, so the answer is second option 0.0.25. Thank you.